The purpose of this video is to walk you through how to efficiently solve and find all of what you're trying to find when you're analyzing this function f of x equals x minus 2 minus sine of e to the x minus 1. So we're analyzing this function on the interval from 0 to 2 using our calculator, so we don't have to do really too much by hand. And I want to show you an efficient way to utilize your calculator so you're not spending time unnecessarily. So the first thing we want to do, noticing that we're going to be finding everything, increasing, decreasing, all of the above, concave up and down, inflection points, and extrema. So first things first, since we are given the function, we want to go ahead and type our function in and define f of x to be our y1. And I'm going to go ahead and zoom in just a little bit so you can kind of see what I'm doing here. And maybe that's a little much, but I think we're good there. And then what we want to do is we want to define our y2 to be the derivative of y1. So we just don't have to calculate f prime and f double prime by hand. We can do this using the calculator. And the most efficient way to do that is to define y2 to be, punch in math 8. So type the keys math 8 or math, scroll down to 8 and hit enter. And you can see we are defining y2 to be the derivative of something. So we want the derivative with respect to x of y1. And to get y1 in that spot, we hit alpha trace, which accesses the F4 options. Y1 is already selected, so we hit enter, or we could have typed a 1. At x equals what? So we could type a number in here, but that's not going to help us because typing a number gives us the derivative of y1 at a certain place. We want the derivative of y1 at all values of x, so we just type an x there. We go ahead and rinse and repeat for the y3. So we want to define y3 to be the derivative of y2. So math 8 with respect to x, alpha trace. Now I could hit a 2 for the y2, and then x equals x. So we're going to have all three functions, f prime, and f double prime. And I'll show you how to deselect one of those, two of those, so we can focus on just one. But here we are, we have our three functions defined. And before we hit graph, that's kind of rolling the dice. We don't want to do that yet. We want to hit window and adjust our window to match our domain interval that we were given. So we're given that we're trying to analyze this function on the interval from 0 to 2. So that's our domain window. Make sure your x scale is at 1, keeping things simple. And then you could go from -3 to 3, and probably the graph of the function will be in between those two values. And then xres 3, always make sure you change the xres to 3. And now hit graph. And you can see the blue graph is our f of x, the red graph is f prime, and the green, I guess that's green graph is f double prime. It gets kind of confusing when we're looking at all three graphs at the same time. So we want to hit y equals again and deselect the f of x by moving the left arrow, hitting the left arrow, and then put the cursor on the equal sign and hit enter. Put the cursor on the equal sign for y3, which is the second derivative, hit enter, and then we're going to go ahead and only look at f prime. So that's f prime. We want to know when f prime is equal to 0. So f prime is equal to 0, second trace, calculate the 0, enter, move the cursor to the left of that 0, hit enter, move the cursor to the right, hit enter, back it up a little bit, hit enter again, and we get that the 0 is at 0.725, rounding always to 3 digits. We want to quit that and we want to store that value. So push, get a clear screen by hitting second quit, and then push the independent variable button, the this one right here, that one right there, just to the right of the green one, and then hit enter, and now that x-intercept for f prime pops up on the screen, and we want to store that STO with an arrow to the left of the 1. Store that, it takes your answer and it stores it wherever you want to, and I'm going to hit alpha math, so I'm going to store it in position A, and then hit enter to lock it into position A. That position A value will not change until you store another value in A. And so I'm going to show you a different way to get the other x-intercept. And the other x-intercept, second calculate 0 again. Now, I could continue to move hit my right arrow to get that cursor over there, or I could remember that my window here goes from 0 to 2 from left to right, so I could just, it's asking me, prompting me to type in a left bound, or to indicate a left bound, so I could just type a 1, enter, and it locks in the left bound at x equals 1, and then I know the right side of my screen is 2 units, and so I could just do like 1.9 for the right bound, and it'll lock it in there, and then my guess, I could just back it up a little bit and type in 1.8, and then it gives me my second x-intercept for f prime. All right, so now I've got that. I'm going to do that same thing that I did with the first x-intercept, and I'm going to clear the screen, back out, hit x, enter, and now we have a new x in there. I'm going to store that in alpha b, enter, and now, because I'm going to use those values later on, I want to have them stored, or just in case I'm going to use those. It doesn't take that long to store those values. Now we're going to go ahead and do that same thing for f double prime. And so we're going to highlight the equal sign for f double prime, and we're going to hit graph. This is our f double prime, and we're going to do the same thing that we just did, and we're going to store those zeros in alpha C and alpha D, okay? So second calculate 0, left bound 0.2, right bound 0.8, guess 0.5, and we get the first 0 at 0.45, we should, yeah, 0.45, and we're going to quit that. We're going to get x in there, we're going to store that in alpha C, okay? And then we're going to do the same thing with the other x-intercept, and the other x-intercept has a left bound of 1, a right bound of 1.9, and a guess of 1.5. And so there we have our second x-intercept for f double prime, and x enter 1.474. We're going to store that in alpha D, and you can see that all on my paper, and that's pretty much, oh, there is one more thing. So I'll zoom out here. So here are the solutions. Here are the solutions. Here we have the f prime test, and we have the a and the b values, okay? And then we have the f double prime test, where f double prime is 0 at the c and the d values, okay? And our explanation, I'll be posting this as well. Now, the inflection points, remember that 0.45, that's our value that we stored as value c. Let me just show you that one last thing here, and then you can do the rest. Let me zoom in. And if I want to get f of 0.45, I know that 0.45, I labeled that on my paper as the value that I stored in position C. So clearing the screen to keep things simple. Alpha trace. Now what do I want? I want f double prime, and that's my y3. So I want f double prime at position C, alpha C, and if I put parentheses there, so I have f double prime at C at 0.45, and that is not supposed, oh, sorry, I totally messed up. We don't want f double prime at C because we know that's 0. We want the position of the graph of f1, of y1. So we want f of x at C. So we want y1 at C, sorry, y1 at C, and that's negative 2.088, and that's the number that we have right there, okay? So you could rewind it if you didn't see that, but when x is 0.45, the y coordinate is negative 2.088, and that is an inflection point because, why? Well, it's an inflection, let me zoom out a little bit here. It's an inflection point because of F double prime changes sign there. So F double prime changes sign at both of these, and if we want the y coordinate, we do what we just did. And then you can analyze here. I'm kind of hurrying because I've got students outside my door. Class starts in a minute. We have the endpoints. So this is our find and classify our relative extrema. We have to find the y coordinates of the endpoints. We have to find the y coordinates of the critical points, and we analyze. The lowest of all the low y values is going to be our absolute minimum. When we look back at our sign chart for f prime, we can see that at the endpoints, from the left endpoint, the f prime is negative, so the function is decreasing. F of x is decreasing on that interval, so we have a max at x equals 0. That makes 0, -2 a local max. And then we have an absolute min. We already talked about that. F of 0.725 gives us -2.15. That's a min, and that's our absolute min. We have another max at 1.772, and that's an absolute max because there's two max values. The higher of the two is our absolute. The lower of the two is our local. And then same with the mins. There's two mins. We have an absolute min that's lower than the local min. Okay, so there you have it.